All right. So, welcome to part one of my 2-day exam one review. So, if you haven't had the pleasure of working with me, my name is Liz and I am one of your TAs. Today, I decided to do this exam review and record it early and upload it to YouTube so that you guys can utilize today to look over this on YouTube and or attend other sessions for exam review that other TAs may be holding, or our supplementary instructor, SI, Lexi, is holding. So my first part one of the review was originally going to be from 4 to 6 p.m. today, but I am going to cancel that, as you will soon find out via your email and announcements, and I will be providing you this video and access to this video for your viewing pleasure at any time today or tomorrow. However, I will reiterate that I will be doing the second part 2 of my exam review tomorrow, still tentatively at 4 to 6 p.m. So tomorrow, part 2 review will still be held from 4 to 6 p.m. Okay. So again, I'll put on here no review today, which is 2/10/21, but we do have yes review 2/11/21 from 4 to 6 p.m. Okay, so again, no review today, right? That's why I'm making this video, but we do have a review tomorrow from 4 to 6 p.m. Okay. All right, so the first thing I want to do is just briefly talk over this agenda. Feel free to put me on 2x speed if you'd like. The first thing is please complete your assignments. Even if you are, in quote, late, with the exception of mastering chemistry, sometimes mastering chemistry closes things out. Regardless, whatever you have not yet completed, okay? So if it's your first chemistry and pictures, or which will be tomorrow, you're up to chapter 3 post-lecture mastering chemistry, or even Sir Martin, get those things done, okay? Email me and get them done, please, all right? Second thing, please, please, please stay in constant communication. This class has a tendency to become very back burner, as I've told a lot of you already, and so sometimes the assignments fall by the wayside. That's not saying that everyone in this class treats this class secondarily. I'm just saying because there's a lot of leniency in this class, it has a tendency to take a back seat. Please stay in constant communication. The moment that you do not communicate to me, any of the TAs, the SI, or Professor Richmond, and you are falling behind in the assignments, we're not mind readers, so we can't help you, okay? And there is a thing, too late, too sorry, all right? Please, 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 if something is happening in your life or you just need a mental health day, email me and I'll make it happen, okay? So the biggest thing, and worth 0 points, but has the most benefit to your success in this class, is your communication, okay? Email me, we can request a Zoom meeting, or I can send you a PDF with some walkthroughs on particular problems, okay? Whatever works best for you, you need to communicate, okay? But that is the biggest thing here. All right, TA sessions. I want to get your feedback from those. Also, I need to put on here the altitude survey, okay? That's found in the lab, but we'll get there. TA sessions, I want to know your feedback. What do you like or not like? Do you go to the TA sessions? If you have gone to the TA sessions, have you only gone to one TA that was in quote in charge of your section, or have you experimented with the other TAs, Dom and David? Again, what works best for you? Notes, a micro lecture for the TAs to have something planned. Do you just want it to be kind of an office hours where you come in with your own questions, or do you just like to sit in the background and listen and maybe gain some understanding, or kind of listen on and quiz yourself just as a spectator? Also, why or who do you not utilize? Do you not utilize the TAs? Do you utilize the TAs? Why or why not if you do or don't, okay? And as far as the SI, reminder, she is not a TA, right? She is the supplemental instruction for this class, meaning she provides you extra chemistry knowledge and also covers the topics that we've talked about in class. Sometimes it's a little bit more in-depth and sometimes it's very superficial. But again, she is supplementary. So she is just another excellent resource for you to succeed in this class. Let's say if you don't like reading the book, you could go to the SI sections and she will kind of go over and reiterate those key things and parts of the textbook. I will also say that I do the same thing, okay? So I'm also very thorough. I don't call myself an SI because I like to grade your work and have a little bit more control in terms of your grade and giving you some leniency when you're experiencing difficulties, right? So that's why I like being a TA. But as far as the thoroughness of my reviews, of my office hours or TA Zoom hours, I would consider myself equally as thorough as the SI. It is just depending on me understanding where you're coming from, okay? I am very capable of holding micro sessions, but most of the time students come to me with homework questions. And so it would be kind of hard to establish a micro lecture if we're always going over homework, which most of the time we are, all right? Okay. And then the last thing is, oh, and as far as your feedback, please email me. Email me. Every single time something is working for you or not working for you, or you don't like something, or there's a disconnect, I want to hear about it so that I can fix it, okay? I want to tailor this class individually to each one of you. There's 180 of you. So I really want to make sure that if you are watching this, that your voice is heard and that I will make those accommodations to make sure that you are maximizing the most learning out of this class and preparing you for nursing school. Okay, with that aside, that's our agenda. Today, I'm going to kind of go over briefly on how to do well on the CHEM-1130 exams. These are tips just to do well for this class. Now, some of these tips you might be able to spill over into your other class. That's great. But for CHEM-1130 specifically on these exams, this is how you will do well. First of all, you have to know your vocabulary, okay? You have to know it inside and outside. If you don't know the vocabulary, it's going to easily trip you up, okay? Proton, neutron, electron. When we say proton, you must also know that we're talking about hydrogen ions, okay? There's a lot of different words that we use to talk about the same exact topic. And protonation, okay? So we just have a bunch of different words that kind of all mean the same thing. Some of them are just a little bit more politically correct or specific is what I like to say, right? So you must know your vocabulary, okay? If you don't, start making flashcards for that, for the words that you don't know so that you can go back and make sure you do know them, okay? Because that is the first tip to doing well on these exams. Second, read the question at least 2 times, not 2 times, at least. Read the question carefully, slowly, 2 times. You have enough time on these exams to make sure that you are very thorough. Some students can even quadruple check their exams. You have enough time, take your time, read it slowly and carefully. And the reason I say that is because our brains are so used to working from left to right. And we read left to right. And so we think left is start and right is finish, okay? But the way that some of these questions are set has your mind working backwards, okay? So you'll be given the solution and you got to figure out what the question is. You'll be given the product and you need to figure out what the reactant is, okay? You'll be given the last significant figure in the unit, but you need to set up what if the end game was grams, maybe we were starting with kilograms, and that's something that you will need to problem solve and figure out, okay? So I'm just letting you know, those are also called softballs, okay? So if you're practicing the stuff from the exams, from the exam 1 folder, don't just get used to that layout. You need to approach it from left and right, reword it, restructure it, rephrase it, okay? Because that's how you'll succeed on his questions. Make lists. What do I mean by make lists? I mean make lists for when you're solving the math problems. Chemistry is a lot of words. It's a lot of words, a lot of storytelling. And really all we need to know is just information that we can use to plug into an equation, okay? So if it's giving you a word problem and it tells you all this weird stuff about it, you need to figure out, okay, what is the final unit that my answer needs to be in? And then what information am I given? You're always going to be given a temperature. But if your equation doesn't require you to use temperature, then that's moot. You don't need to even think about it. Okay, so figure out what the question is asking. What is the end result? Then make a list based on the information you have and pick which ones work, what parts of that information is important and the other not so much. Okay. Again, we talked about know what the question is looking for. Okay. And watch your units and sig figs. When you're taking an exam, a lot of test anxiety kicks in and you'll see 42.3 grams, you'll see 42.3 milligrams, okay? And a lot of students forget about the SI, the units, all right? But they see 43.5, that's what their calculator said, that's the first thing they click. Make sure you pay attention to units. He will double up on the numbers that the correct value, but he'll change the units. So make sure you're paying attention to not only the units, but then the sig figs, okay? Remember, you can only use the least amount of sig figs in the problem. So if my temperature was 25 degrees, but then I had 0.1234 moles and 0.6439724.6, I only can use, if I use the temperature in part of the equation, I can only use 2 sig figs for 25, okay? So you can only have your answer can only contain the amount of sig figs that's the least number in the problem. All right, and if you have questions on that, email me. All right, so now what we're going to do for the next hour and 45 minutes is go over exam, a practice exam. This exam is something that I have. It's not going to be on the exam folder, so make sure you kind of listen to these questions. If they're clicking, you can rewind, fast forward me, but these are questions that have been used in the past on these exams, okay? Remember, this exam is through chapters 1 through 4, cool? All right, so the first thing that the first question is, and remember, it's all multiple choice, okay? So one question would be, you need to know, the question will say, which of the following is a non-metal, okay? So I'm gonna write non-metal. So which is not a non-metal? Is a non-metal, okay? Which one is? All right, and then we can choose from Al, which is aluminum, we could choose from magnesium, we could choose from sodium, or we could choose from chlorine, okay? And you'll have to just click which one. So which one of these is not a non-metal? Okay, well, non-metal is considered our trash zone on the periodic table. It's all that stuff in the middle that's not in the columns 1, 2, and then, up to 8. Okay, it's that middle tiny dip in the center of the periodic table. And this is there, and this is there. So that's the only answer that we have. Okay, so the answer is chlorine. What is the correct symbol for copper? All right, so this is gonna, again, why we allow you to use a periodic table. So I'm gonna say symbol for copper. All right, and he will give you CO, Cu, Cr, or Ca. Okay, well, this is calcium, that's chromium, okay, and this is usually where people get confused. This is cobalt, and so this is the correct answer. All right, Cu. All right, another question he could ask, which of the following is an example of a heterogeneous mixture? Okay, so hetero. Okay, so which one is a heterogeneous mixture? We've got blood. Okay, we're gonna have sugar water. We could have air, and we could have vodka. All right. This one tricks people up. So the first thing that you need to think about, remember back on my tips and tricks, is you need to know what it means for something to be heterogeneous. Okay, heterogeneous is a mixture, all right? It's a combination of a bunch of different things, not the same thing, okay? So a lot of people will say, well, in the air, in the air, we have carbon dioxide, oxygen, nitrogen, we have all these different things. But in theory, okay, those aren't what make up air, okay? So it's not, for this question, it's not air, all right? And that's a tricky question, because in your mind, you're going on this molecular level, all right? But that's not air, okay? And then vodka, we distill that, right? So we distill and we take out all the impurities to try and make it pure. So that would mean that it has to be all the same thing in there, which would make it a homogeneous mixture, okay? So then we're between sugar, water, and blood. Well, sugar, water, it's two different things. It's water and sugar, okay? But if you think about it, we have aqueous solution here because water is dissolving the sugar. So that doesn't mean that it's a heterogeneous mixture, okay? So the question, the answer here is going to be blood, because blood is comprised of proteins, plasma, enzymes, white blood cells, obviously red blood cells, and sometimes there's a little bit of hormones, and there's all these little bits and pieces inside blood, okay? So blood and all of those things would not exist. Blood would not be blood without that, okay? So that's what makes something a heterogeneous mixture, right? Blood can't just be a red blood cell. That wouldn't be blood anymore. It'd be a erythrocyte, which is fine, but it's not blood, okay? So you can't, for something to be heterogeneous, it has to be heterogeneous. It can only be heterogeneous because if it were any other way, it wouldn't be what it was. Does that make sense? So blood is not blood with all those other components, okay? That's heterogeneous. All right. The next question we have is you'll be given some formulas, empirical formulas, and it'll say how many O atoms are in this formula. Okay, and then we can have 5, do we have 7, do we have 3, or do we have 4? All right, so how many oxygen atoms are in here? Okay, the biggest hiccup here is your basic math. Do we add those subscripts? Do we multiply those subscripts? How does that work? Okay, so when you're doing this question, all you have to do is this is multiplied. Okay, so in this out here, we would have 2 nitrogen and we'd have 6 oxygen, and then an oxygen out here is 7, so we'd have 7 total oxygens, okay? We don't add, all right? We don't add, and you can see that because if you did add 3 and 2, that would be 5, so we know it could be 5 because we have an oxygen here, right? 3 and 4, a lot of students would say that there's 3 and 4, that there could be 4 because that 2 is just, okay, well, what do I do with the 2? Nothing. They think it's a charge, okay? And we don't subtract. So make sure you're aware of how to use subscripts and how to add them. All right. Another thing that you'll have to do is balance equations. So he's going to ask, what is the coefficient of oxygen, or I should say O2, when the equation is balanced, okay? And you need to have the lowest whole number in the coefficient. Okay, so this is what it looks like. We're going to have C2H6 plus O2 yields CO2 plus water. Okay, and your options are 4, 3, 6, and 7. All right, so let me just show you a trick here. Don't try to put other values in when you're trying to solve this. Look at the selections that he gave you. He gave you 4, a 3, a 6, and a 7. Take those and plug them in and try to balance, okay? Because the thing is he wants to know just of oxygen, all right? And it has to be the lowest whole number. So if I put a 4 in front of this O2, that means how many O2s would I have, okay? And then if I had you have to just think, okay, which one of these balances everything on the other side? If I have a 4 in front of this O2, okay, 4. And then I'd have a 4 in front of this CO2, that'd be 4, but then that's 5 oxygens. Okay, so we know it can't be 4. Let's put a 3 in front of this O2, so 3, okay, and then we'd have a 3, if we put a 3 here, right, then that would be, that's 3 and that's 4, so that's still not balanced, okay? So you have to go through all of these and think which one is gonna balance both sides. Give me the same number of carbons, the same number of oxygens, the same number of hydrogens, okay? And we're only looking at the coefficient here, all right? What number goes in here to balance both sides? So if I have a 4 in front of this O2, that means how many O2s do I have here compared to here, okay? If I put a 3 in front of this O2, how many O2s do I have on the left and how many O2s then would I have on the right? If I put a 6 here, how many O2s would I have on the left? How many would I have on the right? If I had a 7 here, how many O2s would I have on the left? How many would I have on the right? Okay, and you have to think about that's what balances everything out. Okay, so if I did C2H6 plus 7O2 yields CO2 plus H2O. Okay, so I'm putting the 7 in front of the O2, like the question is asking, okay? And now the thing is okay, so how many O2s do I have on the left? Right? You have to think, how many do I have on the left? And so then if we had 2 on there, okay, if we have 7 here, do I do 7 times 2 to give me 14 oxygens? Or is it just 7? Okay, do we add those or not? If you have a coefficient in front, do you multiply the subscripts? Okay, because that's O2 gas, right? The first thing is, these are the tips. The first thing when you're doing balancing chemical reactions is things. Never, ever, ever change the subscripts. And 2, always, always, always multiply the coefficient okay, okay, so you never change the subscripts, okay, but you do need to take the coefficient, this is the coefficient, okay, and multiply it by the subscript. So here I'm going to have 14 oxygen, so I'm going to put a little 14 down here, okay. Now on the right side, I technically have 2 oxygen and there's another oxygen, so I have 3 total oxygen. So before I balance this, let's look at carbon really fast. I have 2 carbons here. How many carbons do I have here? That's only 1. So for this to be balanced with this, I'd have to technically put a 2 here. So now I'm going to have 2 carbon and 2 carbon. Okay, that's fine. But then this 2 also gives me 4 oxygen. Now I have 1 extra. That's a 5 oxygen. That's still not the same. Okay, so let's pause here for a second and look at the hydrogens. I have 6 hydrogens here. How many hydrogens do I have here? 2. So if I put a 3 here, then that would give me 6 hydrogen and 6 hydrogen. That's 3 oxygen and 4 is, that's 7, right? Okay, so we have to keep going so that we have the same amount, okay, right? So this is something that I want you to kind of practice using these rules, okay? And we'd have to keep upping these up. So these numbers are all going to keep going up, all right? But the answer will be 7, but I want you to try and practice this before I spend too much time going over that, all right? The next thing that he'll ask you, we're on question number 6, is going to be, which of the following is a chemical reaction? So circle the chemical reaction, okay? So we've got slicing of ham, okay? We'll have rusting of iron. We could have liquefying oxygen. And so, or even you could have melting ice. Okay, so out of these, my thing is a chemical reaction. This liquefying oxygen is not going to be a chemical. These are just physicals. Okay, slicing of ham is just physical, is in a sense physical, because you're going from a whole piece to a slice, right? So we're not really even, we're just altering a few things of it. The answer would be rusting iron. All right. Again, this one, this liquefying oxygen is going to throw most students off. So that's why I said read things carefully. All right. The neutral atom. So a neutral atom always contains what? Okay. And again, everything is going to be multiple choice. I'm not going to write all of these down because sometimes they're very long, but I will read them to you. Does a neutral atom always contain the same number of neutrons and electrons? Does it always contain the same number of protons and neutrons? Does it contain the same number of protons and electrons? Or does it contain the same number of protons, neutrons, and electrons? Okay, the term here is neutral atom, so that is telling you that there should be no charge. Okay, so for something to have no charge, you only need to think about things that do have charge, and that's your protons and neutrons. Okay. 8. Which subatomic particle contributes least to the mass? Okay, so what subatomic particle contributes least to mass? Notice how I wrote least big. He won't do that, okay? You need to read. So we have, is it the neutron? Is it the proton? Is it the electron? Or is it all of them? Okay, well, if it were all of them, that would be saying that protons, neutrons, or electrons don't contribute to any mass, and we know that that's not to be true, okay? So what makes up the mass number? The atomic number, okay? We have the atomic number is the top part of the periodic. What makes up the atomic mass, okay? It's what and what? It's protons and neutrons, right? Okay, but those contribute the most to the mass because that's what makes up the atomic mass. What don't we talk about ever? This guy. Electrons do not contribute to mass, okay? They're usually in terms of the radioactivity and not radioactivity, the reaction, okay? If we have cobalt, CO, and I'm gonna write cobalt here. And this is element, and he tells you it's element 27, okay? Then we'll talk about cobalt 60, all right? And we talk about how that's in a medical treatment. How many neutrons and protons? So how many neutrons and protons are contained in this isotope. So the isotope being cobalt-60. Okay, so if he gives you this information, you can easily go and try and figure out how many neutrons and protons are in cobalt-60, right? Because what does this number tell you? Okay, so you have to think about what is that 60 telling you? And then if your element is 27, right? Then we could just do some subtraction here. And we'll figure out that the answer would be there's 33 neutrons and 27 protons. So what does this number tell us? Okay, it tells us the number of protons. So if 27 equals P, right? If 27 is our protons, so we'll put a P down here, then 27 has to be the total number, cobalt-60 minus something. So what is 60 minus something? You can take this equation and you can solve for X, and that's how we'll get the number of neutrons, okay? Because this number is, that 60 is telling me what? Is it a mass number? Okay, so that's how you'd solve that question, right? Again, they'd be multiple choice, so you just have to make sure you do your math right. Which of the following represents a pair of isotopes? Okay, so which is a pair of isotopes? Okay, if you don't know what an isotope is, again, that's terminology. You need to make sure you know your vocab/terminology, all right? So we have this 11H, and then we'd have 21H. We have an option of having O2 and O3, and then we'd have an option of 14,6 and carbon and 14,7 nitrogen. All right, I'm gonna put that there. Which one of these is an isotope? Well, an isotope is, there's basically no change in the term of atoms, the number of atoms we have, or what those atoms are, okay? So what I mean by that is if we're talking about carbon, there's no way that an isotope can then consist of nitrogen, okay? That's a completely new element. You have the same things. It's like saying, okay, if I have a smiley face drawn this way, I have two little lines and a circle, like a half circle. This, an isotope to this smiley face would be this. Did I change anything with about the three little marks on this paper? I still have the two straight lines and a half circle? No. The only thing I changed was the way that they were arranged, okay? So in this case, for something to be a pair of isotopes, these are two completely different molecules, all right? O2 and O3, okay? What about this? It looks weird, but protons and neutrons may change. Did we add anything different? Did we change anything? No, okay? So that would be a pair of isotopes, okay? I was giving you time to think. All right, the next question. We're gonna be talking about the half-life of a specific radionuclide, okay, nuclide. So if we have some sort of a half-life, the half-life of a given radionuclide, okay, is 8 days. How much of an 80 milligram sample will be left after 24 days? Okay, for a problem like this, the best way to solve this is a formula. Sorry. I want to make sure that it's on your sheet. Okay, so the best way to do half-life is to remember a formula. And I like to know this formula like this. So the best way for me is, let's do it this way. So we'll have okay. So we have 8 days, all right? 8 days. We're going to take this total of 8 days and let's cut it, all right? If its whole entire life is 8 days, okay, like the half-life is 8 days, we want to keep going and figure out, well, what is, how many half-lives is in 8 days, okay? Or how many half-lives are there? So if we think about it, we have to say that 8 days is equal to 1 half-life, okay? And how many in 24 days, then how many half-lives do I have? So blank half-life, okay? So we're gonna go basically 8, see how many times 8 and 24 go, right? So we're gonna say if we have 1 half, and then we multiply that by 1 half, and then we multiply that by 1 half, okay? Then we basically get 1 half to the third, which equals 1/8, okay? So 24 days and 8 days, you'd have to think about it. So 24 divided by 8 is what? 3, okay? So we know that there are 3 half-lives in 24 days. Hopefully that's clear. So the reason that I have it as 1/8 is how we get into terms of half, the 1 half, the half-life, okay? So with that being said, hold on just a second. I will be right back. Okay, there we go. Now you can see me. All right, so if we have, okay, there was a break there because my kid had to use the bathroom. Okay, so where was I? So they're telling you the total amount of days is 24 days, okay? And they're saying that 1 half-life is 8 days, okay? And we denote half-life as 1 half, okay? So that's why you're gonna see me do 1 half times a half times a half, because each one of these is in theory 1 life, right? So that's like those 8 days, okay? So I should actually write this as that's 8 days, that's 8 days, that's 8 days, and that's 24, okay? So that's how we get this 1/8, because 1/2 to the third power, this right here, we're gonna end with 1/8, okay? So from here, then what you're going to do is 1/8 is equal to, or is, then we're gonna take that 1/8 and we're gonna multiply it by the total dose, which is 80 milligrams. And from there, we'll get, that's 10 milligrams, okay? So after 3 half-lives, we'll have 10 milligrams left. Now, where is the formula? Okay, so here's the thing. If you don't remember to do that, and sometimes it's not as simple to do that, here's our half-life formula. Again, test anxiety always kicks in. It's going to be NT is equal to N initial, 1 half to the T over 1 half, okay? Where N of T is equal to the total, the quantity remaining. Okay, spell. Right? Where N0, and this 0 is always indicative of the initial quantity. So this will be our initial. Okay, in here, we're gonna have T is equal to the time. And then the T to the 1 half is equal to obviously the half-life. All right, so if we were to use the same information and plug this into the equation that we learned up here, that we just gave you, you could do that, okay? How much is remaining? Well, we don't know because that's what they're asking. That's what this is. That's how much is remaining. So we don't know our NT, but we do know that our initial amount was 80 milligrams, okay? There's the 1/2 because that's the half-life. The time was, we had, what's the total time that we were talking about? Is it going to be the 24 days? Yes, because this is how much time he says in the problem, it takes 24 days. And the total half-life time is 8 days. All right, so that's how you get 24 divided by 8 is 3, and that's how you get the 1/2 to the third. All right, so you can use this formula if you're a formula person. You just need to know what everything is and where to put what. Because if you put the 24 on the bottom, you're going to get a different number. Okay, but this is going to be something that'll look for on your exam. All right, so that's 11. So now we're on question 12. All right, if we have he might give you a nuclear reaction. So if we have 99 over 42, and we're saying that that is MO, I actually should probably split this in case the student emails me. We'll say that this is MO, not that you need to know what it is. And we're turning this into 99, 43. This is M, and this is TC plus. Okay, he wants to know what radioactive particle is missing in this reaction. Okay, you don't need to know what the M, the TC, the MO, you don't need to know any of that. You need to be paying attention to the values. Okay, we have 99 in the numerator, we have 99 here, 99 and 99. What's changing is this 42 is now to 43. So did we add, or did we or did we subtract? Did we remove an electron? Did we put in an electron? Am I becoming more negative? Am I becoming more positive? What does this mean? If I go to 42 to 43, am I becoming more positive or more negative? Okay, so in this case, for us to become more positive, that means we would be going up. That means we lost electrons. Okay, so we know for a fact that we lost an electron. Nothing happened in the numerator, but something happened in the denominator. Okay, so the right side lost an electron, which is why now we're at a 43. Okay, because it's coming more positive. Make sense? So this is the part that's missing. Okay, the form of radioactivity that penetrates matter most. So most penetrating of matter in terms of radioactivity. Okay, well, you've only learned 3. You've learned alpha, you've learned beta, and you learned gamma. So which one of those penetrates most? Well, we do get some, but this is usually your your smoke detectors, but it doesn't kill us, right? Otherwise we would be mutating all of the time. And beta, we don't really do much with the beta, okay? And so the thing in this one would be our gamma rays. Now, let me just tell you, he also may include protons as one option. He might include the word particles, okay? So it might say beta particles or alpha particles, okay? And then it might say gamma rays, all right? Because gamma is not a particle, it's a ray, all right? So you just have to be aware of that. But these other words will be used to kind of scare you / confuse you. All right, next, which of the following elements contains 6 valence electrons? So what element has 6 valence electrons? Do we have, is it phosphorus, is it chloride, is it silicone, or is it sulfur? Okay, you need to use the periodic table. Remember, it's the group number. So whatever is on the top of each column, that is indicative of the same. So which one of these is in the 6th column? Well, we know that that's going to be sulfur. Okay, so you can go ahead and use that. It's a periodic, it's just, that question is regards to your periodic knowledge. All right, next, an ion with an atomic number. So we have an ion and the atomic number is 34, okay? And it has 36 electrons, right? What is the charge? Okay, you're going to be given, is it plus 34? Is it plus 2? Is it minus 2? Is it plus 2? Or is it minus 34? All right, if we have an atom and the atomic number is 34. Okay, that's the top number. And we're saying that it has, with an atomic number of 34, and it has 36 electrons, then how do we figure that out? It has more electrons than protons, okay? So if something is more, that means it's more negative, so therefore the overall charge should be minus 2. Okay, 16. Let's say we have a reaction of, we're gonna take magnesium, and we're gonna add that to nitrogen. What is the product? Okay, with this, you need to make sure that you have your charges. We know that magnesium is always plus 2. So what is nitrogen? Okay, you have to think, what is nitrogen? Okay, we know that there's 3. So in this case, how, for every 2, 3, how do we balance this out? To be 6, so it would be Mg3N2. Okay, so you need to make sure you know how to take their formal charge, add them together to make this whole molecule neutral, because this molecule is neutral. All right, overall charge. All right, 17. If we have valence electrons, so let's say that our total, the question will say what the total number of valence electrons is in this molecule SOF2. Okay, what is the total number? What's the total number of valence electrons in SOF2? Is it 26? Is it 18? Is it 20? Or is it 24? Okay, the key here is valence electrons. So just go and individually find all of those two. Make sure you're watching for your subscripts, because that's indicative that you have 2 fluorines here. So you're going to need to make sure of that, and you should get 26. All righty. So basically, we're just adding up all the valence electrons. Go to the periodic table, find the group number, and then you got to just make sure here on this SOF that you add twice. Okay. All right, which of the following is incorrect? So which is the incorrect formula for iron 3? Actually, I'm gonna change iron. I'm not gonna do iron because we've seen iron a lot. I'm gonna say cobalt 3. Okay, so then he'll give you a list. So he could say cobalt CO2O3, we could have COCl3, we could have COPO4, or we could have COCO3. Okay, the thing here is you need to look at the charge and balance it, okay? Cobalt 3 has a +3 charge, okay? So if everything is +3, right, what would oxygens be? What is chlorides? What is phosphates? What is copper? This is actually COCO3, that's like a carbonate, okay? So you need to think about in which way, which one of these is balanced, okay? So the answer here is COCO3. What is the molecular geometry of NH3? Okay, well, the first thing that you need to think about is, first of all, do I even know what molecular geometry means? Okay, and the second is, what's the central atom? So I'm going to give you a tip, central atom, lone pairs. Okay, so, and you figure out how many valence electrons are there and then add everything in. Okay, so if N is my final, if N is this and I have 3 things coming off of it, okay, then in this case, right, what would my shape be? Okay. In theory, it should be drawn like this. Okay, so in this case, it would be trigonal pyramidal. Okay. If you need to know more about molecular geometry, you need to email me and I will send you a trick on how and what to remember in terms of that. You always need to look at how many lone pairs there are, what's the central atom, okay? And then the second thing is how many, and I'm gonna write substituents are on the central atom, okay? These are substituents. That's a substituent, that's a substituent, that even is a substituent to a sense. This is a substituent. So technically we have 4 different things. Lone pairs are a little wonky. You can consider them that, but in theory, it's just something that like is another element, okay? So I would stick to this idea that it's another element and then keep this lone pair idea in the back of your head because it's easier for me to remember the main molecular geometries if I differentiate between how many lone pairs it has rather than taking these lone pairs and including it as a substituent, okay? Things get muddy that way. So how many things are attached to the central atom? That's 1, there's 2, there's 3. How many lone pairs it has, okay? That's how you need to work on that. Also you need to know the degrees. Know the degree of the angle. Okay. I'll give you a tip. It's only usually 109, 120, or 180. Okay. And they're going to vary in between that in terms of less than 109, way less than 109, less than 120. Okay. So that's 19. Here's number 20. Okay. Let me think what else I want to include on this review for it, because we do have, so I think he made a typo on this exam. It looks like there's only 30 questions, not 40 questions, but I could be wrong. Let me double check. I'm still only seeing 30 questions. So it's not out of 40, it's out of 30. Okay, you'll need to know which of the following molecules is nonpolar. So you'll be given Cl2, you could be given CCl4, you could be given CH3Cl, and you could be given CH2Cl2. Okay, so you need to know which one of these molecules is nonpolar. And what does something mean for you to be nonpolar? Okay, in most of the cases, for something to be nonpolar, you have electrons are shared equally. Okay, so Cl2, CCl4, all right, so if we have CCl4, if C was our central carbon, then we'd have 4 Cl's this way. Okay, if we had ClCl, here we would have CCl and then HH, and there'd have to be a double bond here because carbon needs to make, oh, that's 3, I mean, so really that was an error on my behalf. I thought that's a 2, so there's that. Okay, so is that equal between everything? And then another one would be CH2. Cl2, Cl2. But then is that really how we draw this? So you have to think, is that equal, right? And so which one of these looks like it would be nonpolar? Okay, so CCl4, if we looked at CCl4, do we have anything that's getting more, is anything like pulling more out of it in terms of electronegativity? Is there any unshared pair of electrons? No, because each one of these all has theirs, everything's happy. There's nothing that's kind of uneven, all right? Well, then you're like, well, what about this, Liz? Cl2, okay? The problem with Cl2, okay, is that there's no symmetry here and it's just a single ClC. So Cl2, if you think about if it's polar or nonpolar, where is the electrons going? Okay, so in theory, therefore, to this question, if he gave it to you, it could technically be one or the other, because this is also nonpolar. This is nonpolar. Okay, let's look at CH3, Cl2. Is it polar or nonpolar? Okay, this one would have to be polar, because if you think about this, chloride is very electronegative, so this is polar, all right? And then what happens with CH2, Cl2? Is that polar or nonpolar? Okay, you have 2 chlorines and 2 hydrogens, okay? And the problem is there's an unpaired share of electrons because there's going to be this partial dipole moment between here and between here. Okay, so you've got a very strong electronegative chlorine pulling this way to the left and this one pulling to the right. So this would be polar. So my fear here is this question could potentially have 2 answers. Okay. That the way to solve this problem is to draw them out. Okay, always identify which one is the central carbon or central atom, if there is a central atom. In this case, the Cl2, okay, is a lot of students are like, well, which one is the central atom? Well, they're equally sharing still. Okay, this Cl is no more electronegative than that Cl. That's like my 2/5. Neither one of them is more than the other. No more is better. I mean, obviously in terms of strength, I'm right-handed, so I might have a little bit more strength. But in terms of just general characteristics, this hand is the same as this hand. Okay, that's what it's like when you have 2 atoms that are the same. But if you have difference in electronegativity, and or you have altering levels of electronegativity, so in this case, you have really weak hydrogens and strong chlorides, this would be a polar molecule because we've got some pulling to the left and to the right. Here, we definitely have some pulling to the right because there's only one chloride. Here, though, we have carbon and all chlorides are just equally pulling in everywhere. They're pulling to the right, to the left, they're pulling up, and they're pulling down, making that tetrahedral. Okay, so there's no real pull in between these 2. Okay, with that being said, this is the first start to the exam 1. You need to be able to do these types of problems and understand these questions. Okay, then the last bit that I'm going to give you before I leave is things that you should know for this exam. All right, things to know. What this is going to do is it's going to start breaking down that. It's gonna, you have an outline in your head of this much. I'm gonna cut it to here. And then on Thursday, I'm gonna cut it again, okay? First thing that you need to know the periodic table, all right? In terms of the periodic table, which by the way, you get to have a periodic table for the exam, you need to know the trends for electronegativity. You need to know how to find and identify valence electrons. I'm going to put this in parentheses that it's the group number, All right, so you need to be able to find the group number. On a particular element, you need to know what the atomic mass is made up versus the atomic number. Okay, also in terms of periodic table, just know the location of the transition metals, because if you know where those are, AKA the trash zone, because if you know where the transition metals are, if you were given a list of elements and only you were to identify, you needed to identify the single transition metal, you would be able to say, okay, it's in it, you could only look in the trash zone and see which one of them is in there out of the list that he gives you from multiple choice. Okay. 2, you need to know your vocab. Okay, so vocab to know. You need to know homogeneous. You need to know heterogeneous. Okay, you need to know, I would say, isotope. You need to know alpha, beta, and gamma. Okay, half-life. I know that sounds silly to put on there, but seriously, you need to know half-life. I would also know the difference between an atom, the molecule, a compound. Okay, know what empirical formula means. Okay, I would know about, I would understand what formal charge means. Okay, I would know about chemical versus physical. Okay, those are things that you need to know for this exam. All right. Also, in terms of the math, okay, the dimensional analysis, that's what I call the math part. So it's called a dimensional analysis. This is what you need to know. Okay, I would know how to go from milligrams to grams, and I would know how to do Celsius to Fahrenheit to Kelvin. Again, remember, he gives you a little cheat sheet formula thing. Okay, but the reason that I'm saying know how to do this is because even if you were given a list of formulas, you might not know how to apply them. Okay, so just know that I can't go from Celsius to Kelvin without first converting to Fahrenheit. All right, and then I would also know states of matter. Okay, what are they? Do they include liquid or aqueous? And I would like you to be able to do them from order of attractions. So from weak to strong and vice versa. Strong to weak. Okay. The last thing that I would recommend that you know in preparation for this exam would be making sure you know bonds. Okay. So polar, covalent, non-polar, covalent, ionic, and hydrogen. Okay, that's pretty much it. So I'm going to leave you here. Again, please email me questions. Or through Canvas. All right. And the last thing to say is I will again be holding the review tomorrow from 4 to 6 p.m. That one we will be strictly going over even the smaller condensed list of what you need to know for this exam, okay? Start here with this review. Look at these problems, understand these problems. If you can do these problems forward and backward, you are in great shape for your first exam, okay? Again, email me. Please let me know what works for you and what doesn't work for you in terms of, have you been attending the TA sessions? Have you not been attending the TA sessions? Take the altitude quiz that's found on the Canvas page. Please, please, please. That is 10 points. All right, just get those 10 points. They can help you out more than you know, wink, wink. So take the quiz, provide some feedback, and then email me if you have any questions, okay? All right, best of luck, and I'll hopefully see most of you tomorrow. Bye-bye.